So now how can we see when we're going live? Is the question.
Oh, I think it says in the corner. I think we're live now.
Oh, we're live. Okay.
We are
Hi,
live.
everybody. Sorry about that. Yeah, we have Protocol Labs with us today, which is fantastic. They have reached out to us when we announced the Builders Club and Incubator. They will share a bit more about what they're doing, but really what they've been doing for the ecosystem, for builders, is just fantastic. And I know a lot of you are building NFTs and projects where you will need their products and will want to hear what today's session is all about. So we have with us Rich from Protocol Labs and Ryan, right?
Yeah.
That we'll just share a little bit more, both about Protocol Labs, about their ecosystem, but also give some practical hands-on advice for your builders. And then at the end, we will have a Q&A session. So you will be able to just post your questions in the pop chat, and I will take the questions from there. Yeah, so with that, I'm handing over to Rich, and yeah, very excited that you're both here. Thank you very much for joining.
Awesome. Thank you very much. Can everyone hear me? Just to double check.
Yep.
Perfect. And can everyone see my screen? I've just started sharing.
Not yet. Maybe we should give it a second. There we go.
Here we go. Beautiful. Well, thank you very much for the intro, Raf. To introduce myself, my name is Rich, and I am the Accelerator Programs Manager at Protocol Labs. And I just wanted to, before we have a fantastic talk from Ryan more about future of storage and how you can build with IPFS, Filecoin, and some of our stack. I just wanted to give you some brief background as to Protocol Labs, what we do, and how you can benefit from. That's good. Great. So yeah, give you some background, how you can benefit, and then also for those who are in the incubator program, we would love to get you on board to our platform. For those of you in the Builders Club, we would love to hear from you. So what I'm going to do is I'm going to leave my email in the chat, and you can always reach out to me to get more info. So Protocol Labs, what is it? Well, we're an R&D lab building the next generation of the internet. It started way back in 2014 as the brainchild of Juan Benet, and since then we've developed some of the core protocols that make Web3 possible. So I'm sure you've heard of IPFS, you've probably heard of Filecoin in terms of actually creating distributed storage, and some of you may have heard libp2p, which is a modular network stack that actually powers a lot of the networking behind the Web3 ecosystems. And what you may not know is that we also are heavily invested in a lot of startups across Web3 ecosystems. Obviously, most of the startups building on our stack, IPFS, Filecoin, but also many are just accelerating the transition to Web3. So we have over 500 startups. The latest number, I think, is 560 in our ecosystem, and these have been at every stage from grant funding all the way through to we now have several projects in the Series D, and we really try and foster that community amongst startups themselves. So you are now part of that. Due to our partnership with CPG, you are now part of that ever-growing community of accelerator teams, particularly those within the incubator. You'll be joining 200 plus startups and that have gone on to raise over 200 million from household investors that you will have heard of, and also working across 30 accelerator programs. And what do you get for being a part of it? Well, first of all, you get access to an exclusive network of mentors. I know CPG, you have some amazing people to learn from, amazing mentors to learn from. And we'll be opening up our platform later this month in terms of getting access to mentors to obviously develop strategy, get technical guidance, and get sector expertise from some of the top founders in the ecosystem. And we also have a fantastic investor network which you can benefit from by being part of our platform. So if you join our team database, we have 3,000 plus investors in our extended Rolodex, but we also have 500 plus active investors within our network. And we host biannual events called PhilVC. One which was most recently run in Singapore, had over 300 investors attending, 15 startups pitching, and another 50 startups presented to or were present at the event itself. We also have a fantastic founder-to-founder community. We had last week we had a lab week. Over the last 2 weeks, we've had a lab week in Lisbon, where we gather everyone from the Protocol Labs network, but also the Filecoin and IPFS ecosystems. And we had actually 40 plus founders who all gathered together for mostly founder-to-founder relationship building and creating strategic partnerships. And then finally, in terms of building, helping teams develop their talent funnel and making sure that they're hiring amazing engineers, but also getting access to three job portals, and finally getting access to all of the educational content that we have via Launchpad, which is our fantastic bootcamp, which you can go through. So the platform that we have, which connects all of this, is called SoftNoise, and you can register very, very simply. Like I said, due to our partnership, anyone can reach out to register. You register your team and personal profile, and then you can invite your team members, create your profile, and then wait for investor activity, but also for mentors. And some top tips to get the most out of it: obviously, make sure your company profile is updated regularly. Do use our mentors as much as possible, but be respectful of their time. And you can also make sure you request invites to some of our global events, for instance, in Singapore, Lisbon, and we have Dubai coming up in early March. Awesome. So who we are on the Accelerator team is myself as programs manager. We have Yaya, who works on SoftNoise and data integrity. We have James, who works on growth, and Ruben, who's the partner in the Builders Fund. Please don't be a stranger to us. You can see here, I will share some links in the chat. We have our Filecoin Slack that is public and open, so you're welcome to join. We have 20,000 people on there, and it's a great way to get more immersed in the ecosystem. So I realized that was a whistle-stop tour. I've also been very sick over the past day, so thank you for bearing with me as I go through that. Does anyone have any questions on Protocol Labs and the network?
Yeah, we already had some questions in the chat. Chrissy is asking if the investors that you have in is it called SoftNoise, the program?
Yeah.
What startups they're interested in, and if specifically if they're interested in DeFi.
Yeah, it's cross vertical, so then they're sort of vertical agnostic. We have a huge range. If we go back to this here, if you see some of the startups in the ecosystem, it really does vary from some like deep tech infrastructure stuff, some hardware stuff, but then also a lot of NFT projects. We have metaverse, we have DeFi. Really does vary across a wide number of verticals.
And then Mustache 3 is asking, at what stage of startups do they typically invest in?
Sure. So if we go to this one, actually, what you can see is we have a series of programs where teams can get involved. So if you're very early stage, then you might obviously be eligible for a hackathon, but also maybe eligible for a grant if you have a specific project mapped out and want to get anywhere from a 5K micro grant all the way up to a 100K open grant. If you're working on a specific use case, specific challenge. In terms of our accelerated programs, these are often with startups that are at seed or maybe pre-seed. And then we also have a PL Ventures team that once you've completed an accelerator, really varies from seed, so sort of like 100K ticket sizes, all the way up to into the millions.
Cool. And then the last question is, when you sign up to Soft Noise, how long does it normally take till they hear from an investor or mentor? Like, what can they expect?
Well, it depends on the project and the team, obviously. So at the minute, we are, as I mentioned during the mentor, we are still building out a lot of the functionality. So when it comes to mentors, we're actually launching this later this month, or updating from what we had before. The more important way to look at it is we actually have our investors plugged in to the platform, and teams won't get visibility unless they're in the database. So often for very early stage teams, there won't be as much interest, but for very early stage teams, it might be more interesting in terms of the mentor network and to join an accelerator program.
Cool. Thanks a lot. Then, yeah, some people just say Protocol Labs is so impressive, amazing tools. And then someone else said, thank you for being with us, Rich, and get well soon.
Thank you. I will try.
Yeah.
Awesome. Well, enough of me. I now have the absolute pleasure of introducing you to Discordian, Ryan Sum. He is an absolute IPFS and distributed storage guru. He's done a lot of talks with the accelerator teams, one of the leading dev ads we've got. So really excited to get him in front of you and to speak more about building the future of storage. So I will stop sharing my screen and see if this works.
Hey, thank you so much, Rich. I will try sharing my screen. There we go.
Chat, if you hear us, we are now, yeah, okay, super, it's happening.
All right, yeah, we're already ready to go. So, hello everyone, and welcome to Building the Next Generation of Products on a Distributed Web. My name is Discordian, of course, a developer advocate with Protocol Labs. This talk is about 35-40 minutes long, and afterwards, hopefully we'll have some time for some questions. So first, a quick breakdown. Protocol Labs is an open source research and development lab, building protocols, tools, and services to improve the internet. We try to operate in the public and be as open and accessible as possible. IPFS is a peer-to-peer protocol making the web upgradable, resilient, and more open. IPFS itself doesn't rely on any blockchain. Filecoin is a decentralized storage network to store humanity's most important information. Unlike IPFS, Filecoin does operate on top of a blockchain. For this session, we'll be mostly focusing on IPFS, but I will cover Filecoin and some services which make it easy to dip your toes into as well. All right, so what's on the agenda? Today, we're going to learn about the core concepts of IPFS and why it's important. Go over roughly what Filecoin is and how it works. Then we'll talk a bit about how IPFS and Filecoin are related to and complement each other. Using .storage tools, for example, makes this really easy. Finally, near the end, I will tell you some resources you can explore into to learn more about IPFS and Filecoin, as well as where you can go to find our communities and connect with fellow IPFS and Filecoin enthusiasts. So, data, information, and knowledge are a few of the most important assets of our connected era. They're critical to human development. That's why we believe they must be safeguarded, open, and in the hands of the people. But they aren't in the current model. Let's start with that problem. Currently, the Web 2.0 model is centralization. Amazon, Google, Fastly. If any of these fail, which they do occasionally, entire services can go down. As you get decentralized and further distributed, your service's resilience increases as the users themselves are what are powering the service. On the right side in the distributed web, Each user is also providing a piece of the network itself. If a user goes offline, the network functions as normal. If a major node goes down, the network can still function as well by leveraging the local peers. It is the champion of resilience and the model I believe will take us forward. So, what's the solution? How do we build a web that is distributed? Well, a key part of IPFS and Filecoin is that they are distributed. IPFS and Filecoin are not the answer to all the problems of the web, but they are the answer to some, particularly when it comes to removing borders and silos for data. Over the course of this talk, we will see that IPFS, a peer-to-peer hypermedia protocol for content addressing, and Filecoin, the world's largest distributed storage network, are important building blocks of this new Web3 generation. Files and folders might sound boring, but really, they're not. So IPFS is the interplanetary file system. What is a file system? Files and folders. Any file with any content. Why interplanetary? Because it was conceived as a way to upgrade the web in a way that would still work when the network stretches across planets. The idea being that if you are sitting on Mars, it may take 1 hour for a request to go to and come back from Earth. But if that content was already fetched by someone else on Mars, then the request should not travel all the way back to Earth for it. And that feature should be provided transparently by the network protocol rather than by something else on top. As we will see, IPFS is distributed by design. No central authoritative servers are storing content, and no central server needs to be contacted in order to obtain the content. Typically, you would upload the content to a server, a location. Anyone wanting to download that content will have to get it from that same location. With IPFS, things are slightly different. In IPFS, you run an application called the IPFS peer. And with it, you become a server, also known as a node in the network. You don't actually upload content anywhere, but instead add it to your node and make it discoverable by everyone else. Any content that is published on IPFS uses content addressing, which is a way of referencing a piece of data by its hash. To do this, we will first need to know how to obtain a content identifier. IPFS addresses content by what it is instead of where it is. It enables you to refer to a file or folder via a content ID, regardless of its location. Let's think of the process we follow when we save data. Locally, it just goes on our drive and is addressed there by its path. The web is no different. When we open a website, we're just opening some files. The difference is that they need to be downloaded from a remote location, and we usually do that using a browser which will print pretty things on our screens. With IPFS, we are also obtaining files from a remote location. However, the key difference here is that we don't need to know the location of the content, but instead what is called a content identifier. Ultimately, the content can be at one or several locations. But as we will see, it does not matter anymore where it is. We switch from a location-based identifier to content addressing by using a CID. Next, let's look at the key technologies making this possible. In order to be able to have content addressing, we need to first create content identifiers for each piece of information that we want to put on the network. Think of this as a kind of cryptographic fingerprint of that piece of content. Every piece of content produces a different fingerprint. All the fingerprints are of the same size, regardless of the amount of content that they represent. This fingerprint, which we named Content ID, can be reproduced anytime from the original content by hashing it. This means that if we obtain a piece of content after requesting a Content ID, we can verify that we were given exactly what we asked for. But what about folders? Folders are really just special types of files, which have lists of files in that folder as content. That list provides the names of those files and, in the case of IPFS, their CIDs. Since a folder is a type of file, a CID can be obtained in exactly the same way as for any other type of file. This means that we can represent a folder or even a full file system using a content address structure. Let's bring it to life. As you see here on the left side, our top level folder has a root content ID. It has two entries corresponding to two folders, and those folders have other entries corresponding to files. Each entry has a different fingerprint. That's visualized with the colors here. This content addressed type of graph is what we call Merkle DAGs, directed acyclic graph. These Merkle DAGs, used by IPFS, allow us to move from location-based addressing to content addressing in a single step. We are just replacing locations with the root CID of their content. The subpaths themselves stay the same. One characteristic of content addressing that I mentioned is that the fingerprints are unique for any type of content. What would happen if we wanted to copy file.txt to the folder of the second user? It means two things. Firstly, we don't actually have to copy the file. We just have to modify the folder to reference the content. Two copies of the same content have the same identifier, so to IPFS, they are the same thing. There is no notion that the same content can be duplicated in different folders in IPFS, because it is actually the same thing with the same CID. We call this property deduplication. Secondly, since we changed a folder, the fingerprint of that folder changed, so we had to update the upper folder too to reference the new fingerprint. This means that the fingerprint from that folder changed, resulting in a new root CID. The moment something changes, you get a completely different CID. Your previous CID references your previous version of the content, which has not been changed. The first step when adding content to the IPFS network is to obtain the content identifiers for that content. This can happen offline at any moment. Once we have those CIDs, the next step is to announce them to the IPFS network so they can be retrieved by other IPFS peers. But what is a peer? And what does it do? Peers in peer-to-peer systems are nodes that are connected to other peers to form a network or swarm. Forget for a moment about IPFS and think about a group of people. If I want to address a person and communicate, it helps if I can identify them, for example, by their name. If we share a common language, so we can communicate. And if we have ways to verify that we are who we claim to be. Same with IPFS and the peers in the network. Each peer has a unique identifier, their peer ID. This identifier is linked to a cryptographic identity, which allows each peer to communicate securely through an encrypted channel. The peers in the IPFS network are peers which support a set of services or protocols. One of them serves to request certain content by its CID from a different peer and download it. But in order to get there, it means that peers need to be able to discover each other, the network transports that they support, be that TCP, Bluetooth, UDP, and the services they can understand. This step is called content and peer routing, and it is achievable through something called a distributed hash table, also known as a DHT. The DHT, or the distributed hash table, is a critical service that each peer runs. You can think of a distributed hash table like a phone book, except everyone helps maintain it. It's effectively a series of keys paired to values, kind of like names paired to phone numbers. In order to get the value associated to a key, for example, a content ID, a peer will need to find some other peer that is storing it. The process consists of asking other peers in the network, who has the value for this key? But not in a random fashion. Remember that not every peer is connected to every other peer. Peers with certain names or peer IDs are more likely to store certain key value pairs. Thus, a peer knows which of the peers it is connected to is most likely to have the value for the key that it's looking for. And if it doesn't have it, it will request information about peers known by the other peer which are more likely to have it. Now that we have a database which is maintained collectively by all the peers in the system, how does IPFS use it? Simple. When the content is added to IPFS, a peer will insert one row in the DHT. Keys are either content IDs or peer IDs. Peers can add rows to the DHT declaring A, their peer ID provides specific CIDs, and B, how to connect with their peer ID. Peers can then query the DHT to find which peer ID is providing which content IDs. Peers can also query the DHT to find information on how to connect to that peer ID. Publishing this row involves finding a peer ID similar enough to the content ID to store the row. In short, any peer that wants to download some content will have to do two things. First, query the DHT to find which peer ID is providing the content they're looking for. Second, query the DHT to find information on how to connect to that peer ID. At the end of the DHT queries, a peer knows who has the content it wants and where to get it. The Interplanetary Name System, IPNS, is a system for creating mutable pointers to CIDs known as names or IPNS names. An IPNS name is a multi-hash of a public key. It is associated with an IPNS record, which is published to the DHT containing the CID it links to and other information such as the expiration, the version number, and a cryptographic signature signed by the corresponding private key. If you want an easy solution for managing your IPNS records, please check out W3Name linked at the bottom of this slide. It's very useful if you want to have some sort of mutable system to point to these immutable CIDs. Now that we've gone over obtaining a CID, advertising it on the network, and locating content, let's take a brief look at transferring content. The last step to retrieve content in IPFS is to download it. Because we know how to contact the peer holding the content, and we know what content we want, we can connect, receive, and verify it. This means that any content received through IPFS is authentic and matches the request. Once content is downloaded, the local peer will advertise itself as a provider for that content on the DHT, making it available to other peers for download. The protocol we use to download files is called BitSwap, and it works for quick discovery as well by asking all neighbors whether they have the content. So in the case of maybe the content you're looking for isn't even in the DHT, sometimes we can find it anyways. So while BitSwap is incredible for fast distributed transfers, it's generally only used from an IPFS node. Sometimes you want to share something that's only available over the IPFS network to your friend who might not even be using IPFS. Or another scenario might be that you are simply unable to run an IPFS node in the environment you're working in. This is where gateways come into play. Gateways are accessed over HTTP and can be used in any web browser as a result. Effectively, a gateway is just an IPFS node that's set up to serve requested data over HTTP. They're basically a portal into the IPFS world and are more decentralized instead of distributed. For example, if you created an app that just accessed IPFS content over a single gateway, and that gateway goes down, then your app is broken until that gateway comes back. Additionally, if you used a malicious gateway, you might not even know you're receiving the correct data. Though, there's actually a solution that was recently released to resolve verifiability via CAR files. CAR files are content addressed archives. With them, you can verify you've received the correct data by verifying the hash within the CID against the hash of the CAR file. Gateways are very convenient, but less resilient. It's up to you to decide what works best for you. IPFS really is useful to anyone who wants to serve or retrieve content on the web, which is almost everyone. As certain pieces of content get more popular, the data becomes more readily available and resilient. You might ask, why would random people help store my digital content? And well, the answer is, they likely wouldn't, unless you pay them, or they like you, or the data you create. Also, if you pay just a single provider, you're kind of losing some of the beauty of the decentralization and trustlessness, because you now have to trust that single provider to make your data available. If their servers go down, your data may be temporarily or maybe even permanently inaccessible. So is there a decentralized and reliable alternative? Well, the answer is yes. And this is where we start talking about Filecoin. Let's dive in. Filecoin is storage designed for Web3 from the ground up. It's compatible with IPFS and other existing Web3 technologies, such as Near, the EVM, its own FVM that's coming soon, and many others. It's cryptographically verifiable, so you can store CIDs on any blockchain, really, and reliably retrieve the same data every time, provided you have a storage deal made over Filecoin. At over 18 million terabytes, that's a capacity which could store almost 3% of the world's data, and the network is still growing at a very rapid pace. This is enough capacity for almost any use cases, and there are many, many organizations and people using Filecoin to store data. Let's take a moment to talk about the anatomy of a Filecoin storage deal. So there's the proof of replication, which proves the storage provider is storing a unique copy of the original data. Proof of spacetime proves data is being stored continuously over time. Storage providers must stake Filecoin, also known as FIL, as collateral to dissuade malicious activity. Storage providers buy FIL, put it up as collateral, must have an internet connection and disk space. They also get paid in and earn FIL to store and retrieve data. Storage providers, the users providing storage and retrieval services, compete on storage, reliability, and speed in an open market based on supply and demand. For permanence, any storage deal can be renewed an infinite number of times by anyone or anything. Filecoin relies on higher order systems like smart contracts or Filecoin actors to enable permanence. For redundancy, there can be an infinite number of copies of the same storage deal. Thousands of providers in the Filecoin network compete for storage deals, which drives prices down. Alright, so now that we've gone over both IPFS and Filecoin, let's look at using them together and what that experience is like today. IPFS is storage layer agnostic, and that's because the magic of IPFS content IDs is that they're a property of the data itself, which makes them storage layer agnostic, allowing for full flexibility and modularity. The fact that it's storage layer agnostic means that you can combine it with the storage layer of your choice. That could be Filecoin, which we think is a great option, but you may also store your data with a centralized cloud storage provider or other decentralized storage solutions. The choice is really yours. IPFS and Filecoin are perfect complements for each other. IPFS is great for fast, flexible retrieval over the IPFS network and can even be accessed through HTTP gateways for users not yet equipped with IPFS. Though IPFS needs somewhere to persist the data, Filecoin answers this problem by offering excellent persistence and verifiability through distributed storage deals, which any storage provider can accept. So let's take a second to talk about storing and retrieving data. Well, we highly recommend choosing a storage helper. They simplify deals and workflows, making it fast and easy to build. They simplify deal making in general, finding providers, negotiating prices, waiting for confirmations, verifying storage. Storage helpers handle all of that for you. You can store to both IPFS and Filecoin with a single call. IPFS for fast, flexible retrieval, and Filecoin for persistence and verifiability. A storage provider with Filecoin integration will ensure you never need to think about these things. So let's talk about a couple of these storage helpers. First up is NFT.storage. NFT.storage is a powerful solution for hosting your NFTs for free, backed up over Filecoin, and available over IPFS seamlessly. It's designed for NFT developers who want free decentralized storage. You simply upload your data and get back an IPFS CID that can be used in on-chain NFT data as a pointer to your content. Storage and retrieval is free. You get properly formatted metadata back. Immediately after uploading, you can fetch it back via IPFS and it's backed up to Filecoin via free storage deals. NFT.storage is easily used via its JavaScript client library, their HTTP API, or it can even be used as a remote pinning service. Next up is Web3.storage. Web3.storage is a powerful solution for hosting your data backed up over Filecoin and available over IPFS seamlessly. Data is immediately uploaded to Elastic IPFS and automatically stored with 6 storage providers around the world. It can be used a variety of ways, including the HTTP API, web interface, and their CLI tool called W3Up. Web3.storage also provides other services such as W3Name, which allows you to very easily manage mutable IPNS records so you can have updatable pointers to your CIDs. So this effectively gives you mutable data with IPFS. I really highly recommend checking it out. So I, again, highly recommend checking out their website to explore everything they have to offer. And last but not least, we have Lighthouse. Lighthouse is designed to be the ultimate solution to your permanent data storage needs. For a fee, you can pay to store data forever. They also have some tooling to assist you with encryption and access control for that data. They have a solid community with great support, so I highly recommend checking out their website at lighthouse.storage to dive in. There are several layers to any application, and Web3 offers no exception. You have storage helpers such as Web3.storage, NFT.storage, Lighthouse.storage, Fleek, Estuary, Infura, Ceramic, and more. There are so many tools out there for storage providing that finding the perfect fit for your project should almost certainly be possible. We have the logic layer as well through smart contracts. They can point to CIDs served over IPFS, stored via Filecoin, a pinning service, or maybe even persisted through sheer popularity. The logic layer offers endless possibilities with so many technologies, including Ethereum, Near, and many, many more. The logo on the far right of the orange box is the logo of the Filecoin virtual machine, the FVM, that's in the process of launching right now. Fully EVM compatible, smart contracts will enable co-locating storage and compute. Finally, we have the front end. This is what you see, and can include typical Web 2 methods like throwing your page on a web server and having some server-side code do some work. But also Web 3, where the website is served over the distributed web, often with integrations like crypto wallets and NFTs. Serving static websites over IPFS is quite easy, so I hope to see more and more Web3 type front ends as we move forward into the future. If you are interested in this, I highly recommend checking out fleek.co, which will show you the works for how to set up an IPFS website, do most of the work for you. So we've reached the end of this presentation. Well, about the end. There's a couple more slides. So now I'll point you to some resources and that you can use to hopefully continue learning and engage with our awesome community. So please come join our ecosystem to learn and build. We have an awesome community comprised of builders who help us foster a positive and productive environment. I highly encourage you to check out a resource, we DevRels compiled of several tutorials currently available at tinyurl.com/learn-ipfs-filecoin as well. There is a lot in there. I hope to see you around, and I'm available quickly on our Slack. So please ping me or send me a DM. I'd love to hear from you. I'm Discordian on related Discord servers and the Filecoin Slack. So that's it for the presentation itself. But now, if we have time for some Q&A, I would love to answer some of your questions. So let's see what there is.
Well, thank you so much, Ryan. That was super interesting. It's like your ecosystem is way bigger than I had realized before. Like, just wow. And so for everybody that is in the chat now and watching this, you can send in your questions now. And we already have the first from Dustin. He's asking for Filecoin. Theoretically, can an independent person be a storage provider? What hardware is required?
Okay, yeah, so that's an excellent question. I'm not as in-depth familiar with a lot of Filecoin questions, just as a caveat at first. But yes, anybody can do it. But at least right now, and I know they're working on lowering these requirements, the hardware requirements are extremely high. I'm pretty sure the most popular implementation for becoming a storage provider would be to run the software called Lotus. And I want to say that running Lotus itself has fairly low requirements, but as soon as you want to start doing things like storage providing, I think you're looking at like over 100 gigs of RAM and fun requirements like that. But if you are interested, I do highly recommend checking out the Lotus website. Also, if you join our Filecoin Slack and you are looking for maybe more manageable requirements, the Filecoin community is very strong and will answer your questions very quickly.
Cool. And then Dustin is also asking for IPFS. If your NFT project is stored on IPFS, is it still possible to lose the data?
Yeah, absolutely. Think of IPFS sort of like a distributed HTTP. So if the web server that's hosting your content over HTTP goes down, the content is gone. With IPFS, one of the biggest advantages you have is you could store it on just your IPFS node, which that would effectively be your web server. You're serving it from there. But the advantage to IPFS is now you can also store that on other pinning services or Filecoin. You can store it with so many different providers, and you're still just requesting it by the same CID. It kind of just makes that process seamless for you.
Cool. And then lastly, he's asking if we could get a copy of the slideshow.
Absolutely. I will do my best to share that after.
Cool. Thanks so much. Then another question is, does IPFS allow for encrypted blocks?
Yes. You can store whatever you want on IPFS. So, of course, you can encrypt the data beforehand. There's even some tooling to do that for you. I'm not sure if Pinata has some tooling, but I was checking out lighthouse.storage website today, and it looks like they've added some features to encrypt your data for you before it's put on IPFS or Filecoin. Totally possible. Whatever scheme you want.
Cool. And then one more question from Dustin. What is the URL of Lotus?
I might even be able to look that up quickly right now. It's lotus.filecoin.io.
Okay, lotus.filecoin. Hold on, lotus.filecoin.io. I just posted that in the community. Right. Please, everybody who's watching this, send your questions in. We have the one and only chance now. Yeah, we have another question. What makes IPFS different from other P2P file systems?
Do you have any examples? Because I've drawn a blank.
I guess maybe there is this Arweave, for example.
Okay, yeah. So Arweave, for example, the way I see it is it's almost like IPFS and Filecoin meshed together with their totally own scheme that doesn't use CIDs. Would be a very oversimplified way of putting Arweave. But in short, doing retrievals and storage over a blockchain will usually be slower. IPFS, because it doesn't have a blockchain, can offer very, very fast speeds, and also literally no storage costs because it's more comparable to a protocol like HTTP. They're fundamentally different things. For me, an ideal world would be where we can see IPFS have the ability to retrieve things from Arweave. I don't actually see any reason that we should compete there. I think they're distinctly different enough. And that would also be the only other peer-to-peer file system that I can think of. Hopefully that answers it.
Yeah, cool. Thank you. Then another question was, is it possible to store private objects in IPFS without encrypting them?
Sort of. If you were to form your own IPFS swarm, and we call this, you can use a feature that we call IPFS private network. So while you can still have your data non-encrypted at rest, and on the other end, it'll be automatically decrypted. What I'm alluding to here is with the IPFS private network is there is a shared key that will encrypt all communications just between this node swarm. And that would be really the only way you could do it. You can't have public data put in the IPFS network and then expect people to not accidentally stumble upon it. Or if you were handling, I don't know, some high-end thing and you have spies going after you, they could probably get the CID somehow. There is no privacy guarantee there. Just like if you hosted an HTTP website and you just had like kind of a secret page that had all your secret information, somebody technically could find it.
Okay. Yeah, that makes sense. All right. I think for now we don't have any more questions that are coming in right now. But if people have questions later, I assume they should join the Discord and ask there, or what is the best place to ask questions when you?
Yeah, I would say join our Discord or our Slack. They're both basically the same community. We have the channels bridged together, so whichever platform you prefer. But if you want to get hold of certain people like me, like very quickly, maybe through DM, Slack would be what I would respond faster on. But if you're just looking for general community help, which I highly recommend going for, definitely hit up the Discord. We also have our forums, and those are great. Like if you have like a long form question that you like really want the answer and you don't just want it quickly, please check out our forums. Yeah, I have a link right there on this slide.
Perfect. That's really awesome. I and you said you will send me this presentation anyways afterwards that I can share it with the community, right? Cool. Yeah. Well, thank you so much for sharing all of that with us. I think it was really interesting, and we will be posting all of the links that you have been hearing about today in the chat now. And then feel free to reach out to Protocol Labs and just get involved in the ecosystem. So Ryan, thank you so much for coming and for the great presentation, and hope you have a lovely rest of the day.
Thanks for having me. I hope you have a lovely day as well, and everyone else here too, regardless of where you're from, if it's day or night or afternoon.
Cool. Then see you soon. Thanks everybody for coming.